What if you could climb into a spacecraft, accelerate to 99.9% of light speed, and return home to find your friends decades older while you've barely aged? I'm GK from Void and Matter, and today we're re-exploring time dilation, the strange consequence of Einstein. It's relativity that makes time itself stretch and shrink depending on motion and gravity. According to special relativity, the faster you move, the slower your clock ticks compared to someone standing still. Imagine two siblings, Anna and Ben. Anna stays on Earth, living through its steady march of years. Ben blasts off in a rocket traveling near light speed. For the crew, the journey might feel like 40 years. For those of us on Earth, 400 years would have passed. Yet Einstein's equations preserve a universal light cone that keeps causality intact. If you volunteered for a relativistic journey, you'd return younger than your peers, but would you recognize the world they built in your absence? Would you feel like a visitor in time rather than a participant? No matter how extreme the speeds or gravity, you can't send information back in time to create paradoxes. This built-in safeguard means time dilation stretches the possibilities of travel and observation without tearing the fabric of cause and effect. They arrive young, ready to explore. While Earth has aged centuries, societies have risen and fallen, languages have evolved, and Earth itself may have changed beyond recognition. Their return would feel like stepping into a completely new world, one they'd never truly known. It promises voyages that shrink vast cosmic distances into human lifetimes. Yet it forces us to confront the reality that time is not universal it's woven from motion and gravity. To him, the voyage lasts just 1 year. To Anna, 5 years have slipped by. Let me know in the comments. If you enjoyed this journey through warp time, subscribe and ring the bell to stay on the cutting edge of cosmic discovery. Thanks for watching Void and Matter Keep questioning the universe. When Ben returns, he's physically younger than his earthbound sister, even though they were born seconds apart. This isn't science fiction, it's been confirmed in our laboratories. In particle accelerators around the world, unstable muons race at near light speed and live many times longer than they should because their internal clocks literally slow down. But motion isn't the only way to warp time. General relativity tells us that gravity also stretches the fabric of time. Every global navigation system, every high-energy physics experiment, every planned deep space mission must account for time dilation to function accurately. And as we set our sights on Mars, the moons of Jupiter, and beyond, these effects will only grow more pronounced. The stronger the gravitational field you experience, the more slowly your personal clock runs. Picture an astronaut hovering just above the event horizon of a black hole. From our distant vantage point, their descent appears to crawl in slow-motion seconds, drag into minutes, hours, even days. Inside the astronaut's cockpit, only moments pass before they slip past the point of no return. Here on Earth, we observe a milder version of this effect every day. GPS satellites orbit some 20,000 kilometers above our surface, where Earth's gravity is weaker. Their clocks tick slightly faster than ours on the ground, and without continuous correction for both velocity and gravitational time dilation. Our GPS coordinates would drift off by kilometers every day. These aren't abstract curiosities, they have real-world impact. Now imagine sending a generation ship on a voyage to a distant star at relativistic speeds. There's another fascinating twist. When two observers move at high speed relative to each other, they can even disagree on the order of events. What one sees as cause, the other sees as effect. Time dilation also challenges our understanding of aging, memory, and identity. As we stand on the brink of interstellar exploration, time dilation is both our guide and our hurdle. So, would you climb aboard a relativistic rocket, knowing you'd return younger, but everyone you know would have aged decades?